How's it going, everyone? Eulier Gonzalez here, exploring now at the intermediate React Native course taught by Grady Booch, a software engineer at Expo. She previously worked as a director engineer of the mobile services at one of the on a creative agency called, oh my god, I have this right here, Formidable, right? Formidable. And well, the idea of this, so the goal of this, for those who wants to write React Native applications, and in my case is because I'm actually working for a bank that has invested a lot of their assets in React Native. I want to know is the entire process onto production. So let's take a look at the preview here and then dive into this course. Oh my god, this is accelerated too much.
Hi, I'm Grady Booch. I'm a developer at Expo, and this is an intermediate course in React Native. In this course, we'll go beyond the fundamentals and build a real-world app with React Native.
Exactly, because the idea here is go beyond the fundamentals, which is something that we explore in other videos in the version 1. As a way to now understand is the React Native and their value proposition as well as the inner mechanism. So for example, the React Fabric, and this is the rendering system and how these things work, what is the different phases and the mechanism that it passes through. That is the render, commit, and then mount, and understand that so these pipelines can happen at different threads, and understand that here with React Native you have now 2 threads. The main or the UI threads, which is exclusively to manipulate is host view, and the JavaScript thread. For it, rendering is React logic and the layout calculation, right? So once we understand at least this mechanism and how can we now build this application and understand the tools around us, such as Metro, Watchman, and again, all of these are Facebook technology. So Metro is this what is like Webpack, but for mobile React Native applications. And Watchman for file watching, changing in files. And also now understand that with React Native, which focus on providing its core features and functionalities, we look at what are the most common, especially on developments, and as a React Native developers, based on the Grady Booch experience here, right? Like how can we now set up our projects using Expo, which is now the framework around the React Native, that it simplifies a lot of the setup process, and therefore the develop and build. So develop, build, and publish your app. Now, we also explore what are these fundamentals, especially the most common UI elements that we're going to use, such as the text, the view, and how can we create our React components in React Native, what is the anatomy and how this looks like, how now this layout behaves behind the scenes, and that is following is the flex formatting system to organize how all of these elements looks like. By default is in the stack. And then now look at the way of how we look at the navigations. How can we deal with this? How in React Native handle this? You have 3 types of navigations. You have the stack, tab, and models, how you can nested navigation. And in this course, we're gonna dive deep into the navigation and how these things work, which is something that I really love to go with. And also we explored how can we use this another common UI elements like view, scroll view, a flat list, and text input, and understand, for example, the difference between a scroll view and flat list. So you want to render a finite set of elements that you want to scroll, or that you know that it won't fit in the viewport. Yes, go with the scroll view. But if you want to render a huge data sets, flat list is using behind the scenes a virtualization component, which is a virtualization techniques that it keep tracks all of the elements that is rendered on the screen, plus a small subset of elements at the top and at the bottom. This is known as the render area. Elements that are way off this render area doesn't get rendered. Now, we also look at how can we explore, how can we use this flat list? What is the finicky aspect of using this flat list? And also something that in this course I'm assuming that we're going to explore that. And components that allow components for enhancing the user experience, such as how you can provide a toggle, the layout animation, the persistent storage, and the custom animations with reanimate, as well as the device interactions, such as haptics and push notifications, whether it's in-app notifications and push notifications, and there's difference between each one of them. So push notification is that somehow you have a server that you need to, that you somehow have this push notifications device that is now sent from their server for your server, and this is used. So you somehow know the push notification device ID in using now a iOS or Firebase servers, so you redirect that to their specific devices. So because that's something what is not easily workshopable, now we look at in-app notification and how to build that. And in fact, we created small applications. As you can take a look at this, known as Taskly. This is Taskly, right? Known as Taskly here. That it works as this is a like a shopping list app, all right, where you can add and remove all of this kind of stuff, add some animations to that, and a scheduler app. So if you take a look at this, like so, blah, 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 and there you got it. Motorcycle watch do in, right? And some animations like that, right? That was quite interesting and quite involved to actually build all of this. So now, in this course, I just want to take notes out of this.
We'll look at advanced navigation patterns with Expo Router. We'll explore more interesting UI patterns to build a plant watering app, use development builds to add advanced features like quick actions, learn about build signing, and the steps you need to take to actually deliver your app to the App and Play stores. After this course, you can use development builds to add
Use developer build.
Advanced features like quick actions, learn about build signing, and the steps you need to take to actually deliver your app to the App and Play stores.
Okay, and what?
Deliver your app to explore more interesting UI patterns to build a plant watering app. Use development builds to add advanced features like quick actions, learn about build signing, and the steps you need to take to actually deliver your app to the App and Play stores.
So, So my goal particularly here on this is to understand that how you can build, okay, is to understand the building, so the understand the most common UI scenarios. Okay, so understand the most common UI scenarios, navigation, advanced UI techniques, and development build, which is that, as well as deployment. Okay.
The real-world app with React Native. We'll look at advanced navigation patterns with Expo.
Exactly. So to understand exact. Let's understand how to build. Yeah, how to build is understanding how to build is exactly. Is to understand how to deploy apps or how to publish. Yeah, how to publish apps using React Native. Yeah, understand how to publish app using React Native. That's the entire goal of this. And then you have now specific goals. For example, specific goals. Right? You have now a specific goal for that. Yep, like this. That is, well, so understand a type, or not only understand, yeah, understand how to publish apps using React Native. That's the entire reason of this. Specific goal: a deep dive into routing and navigation, right? Common UI pattern.
Router will explore more interesting UI patterns to build.
Exactly. With Expo. So explore.
Build a plant watering app. Use development builds to add advanced features like quick actions. Learn about navigation patterns with Expo Router. Will explore more interesting UI patterns to build a plant watering app.
Explore UI patterns. Exactly. Explore UI patterns.
Use development builds to add advanced features like quick
Developer tools.
actions. Learn about build signing, and with Expo Router will explore more interesting UI patterns to build a plant watering app.
Exactly. Ship production ready iOS and Android app with React Native and Expo. Go. That's the entire reason of this. Understand how to publish app using React Native in iOS and Android. That's the end goal of this, man. Using React Native and Expo in iOS and Android. That's the entire reason of this.
Use development.
Right? Grow creating user onboarding. State management with Stun. Okay, let's gonna dive in this. A deep dive into routing navigation. Sunstan, a state management tool. And advanced UI techniques, including full screen models and deep linking. Okay. That is full screen at UI patterns like including full screen model, full screen models, and deep linking. All right. Implementing features like image selection and quick actions. Okay. Implement features like image selection and quick actions. All right. package and deploy your app to store with proper metadata, splash screens and icons. So package and deploy your app to stores with proper metadata. Splash screens and error. Splash screen, and errors. And icons, my bad. Okay, but again, this is the idea behind this course and this series of videos recording this process. Okay.
Builds to add advanced features like quick actions, learn about build signing, and the steps you need to take to actually deliver your app to the app and Play stores. After this course, you can build a production-ready app with React Native. So how do we
Yep. Understand how to polish. Again, it's like produce, because the goal is produce. Instead of understanding, it's more like this. So the goal is production ready apps using React Native and Expo in iOS and Android. That's the entire goal of this.
render a full screen?
So let's get into this, shall we? Let's get into this. Let's get ready to rumble.
Welcome to this intermediate React Native course. You've learned the fundamentals of React Native, so your views, your text, your components, you know the fundamental building blocks, and you're interested in learning more. And that's awesome, so welcome back. And in this intermediate course, we're going to go beyond the basic building blocks of React Native development and beyond Expo. By the end of this
And beyond Expo.
course, I hope that you're going to feel that you have all the tools, resources, and knowledge at your disposal for building production-ready apps with React Native. So material-wise, this course will follow up from the introduction course, but we'll be building a brand new app from scratch.
Now, fair use. 1 second, because I just want to take notes out of this course. And I already received a red flags because you can now record yourself with this and take notes out of that. So you can essentially you can publish this content out there, even though that you are doing that for learning purpose. It's not allowed to. So you're gonna receive some sort of some sort of flags and some legal notice, Anyway, this is how the word it is. I don't mention to change that, just to learn it, and that's exactly what we're going to do in this course, or in today's video, is to now take notes out of that, right? Okay, so.
Scratch. In this course, we're going to cover some additional topics that didn't make it into the intro course, and halfway through, we're actually going to also leave behind the Expo sandbox and work with development builds to add a couple of features that wouldn't otherwise be possible. I just mentioned that it is possible to development builds to add a couple of features that wouldn't otherwise be possible, and to also leave behind the Expo sandbox and work with development builds to add a couple of features that
Exactly, because that's what we're gonna do here completely. So who is the score for? No, there's no need to. For those who know the fundamentals of React Native and their value proposition, right? And here we go. In fact, let's go to, we can stick with this, right? We can stick with this. And now the resource for this all right, this is not any longer here. Exactly. Legacy go. just for demo purpose, right? And then you got it with the apps and discussion forum and all that kind of stuff. All right. And now the resources that are relevant for ourselves, which is a current course website and previous course for this. Now, yep, like this. All right. React Native Bridge, if you can take a look at that, but this actually doesn't work any longer. And the course in itself as it is. So you say get started. This is now the intermediate right now, so we are going to be able to describe and build this kind of applications, right? Take this one. Right, there you got it. All right, cool. Is this? So we're gonna see this particular topic, new project navigations here. All right, custom button, linear gradients. You know, some other patterns, UI patterns here. Local image, plan management UI. Full screen model, new plan form, store and list plans, choose a photo, dynamic routes, development build, which is what we really want to do after all, splash screen and app iOS. All right. So we're gonna leave now the Expo Go, which is this nice little wrapper that allows us to test or this small apps for ourselves. So we're gonna now go for a development build, custom functions, quick actions, okay, Expo quick actions. No, not it is time to add something that is really is impossible without development build, a quick action. Okay, so we're gonna also look at quick actions for that, which is great. Deep linking. And then build sign in. Exactly. This is now the process. And here is something that we need to dedicate quite a little bit of time, right? Whether it's on Android builds are signed with Android Key Store, like this, and the iOS. And then deploy to store, which is what we really care in this course, right? So let's get into this. Let's get into this.
We'll be building a brand new app from scratch. In this course, we're going to cover some additional topics that didn't make it into the intro course, and halfway through, we're actually going to also leave behind the Expo Go sandbox and...
Let me actually take notes out of this, because I want to increase my vocabulary. Here. Yep. To increase my vocabulary.
And halfway through, but we'll be building a brand new app from scratch.
So here, let's take a look at this. This is the introduction, blah, 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 blah. Yep. So will be
Native. So material-wise, this course will follow...
Material-wise, what in the F? Material-wise. Exactly, meaning. Material-wise, or to a way of using material effectively and sustainable. Material-wise. In Spanish? No. Material wise, content wise. Exactly, but it's reference to that, reference to the material, relevant to material. When they say material wise or content wise, is relevant to the material. Okay, material wise. Okay, material wise. Did you know that?
Up from and knowledge at your disposal for building production-ready apps with React Native. So material-wise, this course will follow up from the introduction course.
Okay, so material-wise, this course will follow up from the introduction course.
But we'll production-ready apps with React Native. So material-wise, this course will follow up from the introduction course, but
okay, we'll follow up from the introduction course, and here's where we add now the introduction course like this. But
we'll be building a brand new app from scratch.
Exactly. But we'll be building a brand new app from the scratch, right?
In this course, we're going to cover some additional topics that didn't make it into the intro course.
So in this course, we'll see some topics that we didn't discuss on the introduction course, right? Like that. So, such as navigation and deep linking.
And halfway through, we're actually going to also leave behind the Expo sandbox and work with development build.
Okay. And show me what?
Cover some additional topics that didn't make it into the intro course. And halfway through, we're actually going to also leave.
Oh, half through what? What is that again, nigga? Half through.
We're going to also leave behind the Expo app from scratch. In this course, we're going to cover some additional topics that didn't make it into the intro course. And halfway through, we're actually going.
Halfway through. Okay, it's passing by. And halfway through. Oh, and halfway through, we're actually going to. Okay. Oh, right, and halfway through, and I mean, okay, and halfway through. Oh, makes sense, man. And halfway through. Jesus. And halfway through. Oh my God. Yeah, and halfway through. Yep, and halfway through. We are actually going to also leave. Yeah, and halfway through, we're actually going to leave the Expo Go. Makes sense.
Going to also leave behind the Expo sandbox and work with.
Sandbox and work with. And work with development builds, which is completely what we want. I definitely want to do this. It's like, yeah, Expo Go is great for building these small apps where you can take a quick feedback to actually make yourself familiar with the fundamentals of React Native. I already mentioned what are those, like the build tools that we need to around that. So Metro, Watchmans, and how you set up your project with ESLint, Prettier, and then have access to the common core features that we can go with React Native, view, text, and then the navigation, like stack, models, and tabs, how you can create this nested navigation. And here we're going to explore that more about this deep topic that we need to go through. Things like text input, scroll view, flat list, and some of this enhance the user experience, like providing a toggle buttons, how you can define some touchables, how you can apply and use some of these touchable areas to provide more enhanced user experience. How you can enhance the user experience by using is the touchable directive from React Native, and also how you can persist the state of your application using an async storage, as well as the layout animations, how you can provide animations per page. And if you require more custom animations, use React Animate for that. And the device interactions, such as haptics, to provide some tactile vibration feedback to the users. And the push notifications, which is or push notification or remote notifications, and the in-app notifications, and combine that with haptics, and build now a app using Confetti, so we can now actually explore that. So again, the idea of this is to now be able to map all of these core features, and therefore, explore now these topics, because all of this was using now Expo Go. And halfway through, we're going to leave the Expo Go sandbox and work with development builds. Exactly.
Development builds. To add a couple of features that wouldn't otherwise be possible.
I had a couple features that wouldn't otherwise be possible. Wait, what?
And halfway through, we're actually going to also leave behind the Expo Go sandbox and work with development builds to add a couple of features that wouldn't otherwise.
Exactly, to add a couple of features that aren't otherwise supported. And to add another couple features. Yep. And to add another couple features that aren't otherwise supported. That aren't otherwise supported. It is possible to bypass setting up your local dev environments entirely.
Be possible. I just mentioned that it is possible to bypass setting up your local build environment for development builds and build in the clouds with EAS. But for this course, we're going to build our development client locally.
Okay, so we can build our we can build our apps using cloud services, like Expo application services. Exactly, Expo application services. That's the reason why I get it. We can build our app using cloud service like Expo application services. Okay. But for this course, we are going to build it locally, which is great.
It is incredibly useful to know how to do this even if you are using EAS for your development builds, because it will help you debug more complex functionality down the line, or if you ever want to create your own native module, it will be easier to iterate.
Exactly. So this development build is tremendous. It's tremendous.
EAS for your development builds.
It's incredible.
Because it will help you debug more complex development client locally. It is incredibly useful to know.
Exactly. So this development build, this development build is incredible. This development build is incredibly useful to know. So this development build is incredibly useful to know, especially when you need to debug your app, when you need to debug your app for complex directive. For complex directive.
Know how to do this even if you are using EAS for your development builds, because it will help you debug more complex functionality down the line, or
it will help you to debug your app for complex directive or functionality, or when you need to build a native model for your needs, or for your client, and for your service.
Or if you ever want to create your own native module, it will be easier to iterate on it.
Allegedly. It will be easier to iterate with.
So for this workshop, you will need to have your native dev environment set up for at least one platform. Just a quick introduction.
Set up the native environment here, like this. And interesting, set up your environment here. So let's get into this. Set up our environment here.
And you notice
where in the F is this, bro?
Well, just a quick hi from me. So hi, my name's Caddy, and I've been pretty fortunate. I worked on a lot of interesting projects. I guess one notable one was I was a tech lead on building the Puma app from scratch. And aside from consultancy work, I've been an active member of the React Leader community. I've contributed to some open source, and I've also presented in some conferences. I also spearheaded building the ReactConf app. So this was the conference app for ReactConf in 2024. And we built it actually as an example, as an end-to-end example that's in stores, that's also open source, that you can go and pick through and see what building a production app with Expo actually looks like.
Conference app for React Conference 2024.
I currently work at Expo and hoping to bring more people into the amazing world of building mobile apps with React Native. So for this course, to follow along, you will need a Mac, Windows, or Linux machine with Node.js installed. And we're going to start with Expo Go, so you should have an iOS or an Android phone as well. And finally, you will need to set up your development environment for either iOS or Android, or both, but I recommend choosing one to begin with. And just for a bit of housekeeping, for the course format, we have this course website, which you hopefully have access to. So it's on GitHub pages. And in this course, we're going to be learning by doing. I mean, that's my preferred way to learn. So we're going to build a little app completely from scratch. And
we're going to learn by doing it. That's so the learning process of uh, learning by doing, and the walkthrough process is what we are going to do. And this is the approach that I really like it. You know, this is the approach that I really love about this.
It's going to be an app to remind you to water your plants. I don't know about you, but I always forget, so I definitely need a reminder for that.
Okay, so we're gonna build this plan to
A little app completely from scratch, and it's going to be an app to remind you to water your plants. I don't know about you.
okay, so we're gonna build. So it'll be.
But I always forget. I mean, that's my preferred way to learn. So we're going to build a little app completely from scratch.
Exactly. So we're gonna build a little app completely from scratch. So we'll gonna build exactly. So we okay. This one. So we are going to build a. So we're gonna build a little app completely from scratch. Okay. So we're gonna build a little app completely from scratch. Okay.
And it's going to be an app to remind you to water your plants.
And it's gonna be a plant, and it's gonna be an app to remind you water your plants. So it's a plant watering reminder app. I think this is great. I think this is properly a plant watering reminder app. Yep. That's silly. That's silly, bro. That's a silly app, bro. That's a silly app, bro. Food Asasi LLC. Oh, from your dog or animals? And then, of course, they're gonna bombard you with some ads. Make no mistake about it. Can I install this? But where are you gonna install that? So you say, hey, this app is available for your device, but makes sense. You keep track my device. Anyway, yeah, all right. Good app for keeping track of plant schedule. What? All right, Plant Daddy. It might silly. Everything start silly, and they become deep and powerful. All right. Jesus. Let me ask Claude if this is safe to assume. So it is, or proofread the following sentence. rather than a complete sentence. If this means to be a title or a heading, it is fine as it is. However, if you want it to be a complete sentence, you could revise it. This is a plants watering reminder app. Exactly. A plant watering reminder app. Yeah, but this is for the title. So in any case.
I don't know about you, but I always forget, so I definitely need a reminder app for that. And we're going to build this incrementally and introduce things that we didn't cover in the intro course, and I'm going to point out various concepts and common patterns as we go. This app will also have an onboarding step, after which you can add some plants to look after, and we'll explore some new concepts on the way. So for example, dynamic routes, quick actions, gradients, and build signing. On this course website, I'm going to follow a consistent structure. So everything that I'm going to cover is also available on the course website. So if you fall behind or you feel like you want some additional information, there's plenty of links and resources here. All the bash commands that you'll need to run in your terminal will be here in a code block.
Yeah, the bash command.
And
here.
everything that I code will be in these collapsible drawers as either diffs or full components. And at the end of each section, where we've added any code to our app, I'll also add this checkpoint. And the checkpoint will point to a commit in the course solutions repo, which will just have a diff of all the things that we've added. So if you look at the history of the commits, it will be a commit for each section. So if you get lost, you can pick up from the relevant section. I also have some annotations here, so I might use a tip or a warning annotation. So tip is just to highlight some useful information related to the lesson that we're on. And a warning is just usually to offer some debugging tips or cautions against common anti-patterns. I think that's it for housekeeping. I hope you'll enjoy the course.
In the case of debugging.
In this course, we will be building our native app on the local machine. So for this, you need to set up your local native build environment. So you need special tools to build the native app locally. For iOS, you need Xcode. Xcode is an app that's available on the Mac App Store.
So here in my case, I already have Xcode.
And if you don't have this downloaded and you want to build your iOS app, this is only available on macOS, then I recommend you start your download now because as you can see, it is a 3.5 gigabyte download, which is wild. And after you've downloaded it, I would also open Xcode, just using command space and type in Xcode. And the first time you open it, it should also prompt you to install your simulators, which is another couple of gigabytes. In order to build Android apps, you need Android Studio. So this is available for Mac, Windows, and Linux.
Yeah. Okay. Here is the step here on the setup function. So this is the setup here. That's right. The setup here. Let me actually put this as the introduction. So this is now part of the introduction here. I'm gonna make it here, that's right. And then the benefit of this, how it works, the old architecture, the new architecture from here, and then the UI thread, and the JavaScript, and finally look at the setup here, right? So for that, you need to take a look at the React Native here, setup, right? Where it leads you to now the set of your environment as it is. Set of your environments in this version, as you might guess. The other is getting started with React Native project with Expo. This is something that they recommend to go with, right? However, even though if you can also use React Native without a framework, however, we have found that most developers benefit from using React Native frameworks like Expo for that, right? However, if you're building a new app with React Native, we recommend using a framework. Start a new React Native project with Expo. You got this, platform support, Android, iOS, TV, and the web. Okay. But again, I want to take note here, hit the brake, because especially if you're going to build application or develop or maintain React Native app for big companies, for example, like the finance sectors and all that kind of, or any huge sectors where the complexity is quite big, you want to go with what they have done and resist the temptation, or not to resist the temptation, is to follow with the stuff that works and then find patterns to make it easy to work with over the long run, right? There's a lot of people in blogs posts that you can see online that tells you is that, hey, you should now include this and this is the new metrics and all that kind of stuff. There are now top tech company that their software developers provide a certain guidelines and rules, most likely recommendations of how you should do the stuff that you need to be done. And especially for when you work for this kind of big companies, the financial sectors, the healthcare, where the complexity of how can we now make all of these different services and components interact with each others in a way that is easy to test. So it is better for those kind of projects to follow some of the metrics or follow some of the design made by Grady Booch, right? For those who don't know him, shout out to Grady Booch. Oh my God, completely, because he only has 69 years old. That's quite astonishing. Well, he's about to have, yeah, 70 years old. So Grady Booch is a software engineer developer. He is the co-founder of the UML, this Unified Model Language, that makes sense for application. It makes sense for industry that has a lot of systems to interconnect with themselves, and they are huge and massive. So in order to handle the complexity of the system and to understand the complexity from different perspectives, the UML, this Unified Model Language, is a great tool for those companies in those industries to understand the entire process and ultimately develop new features and hotfix and bugs to fix bugs. Now, interesting. He wrote this in 29. I agree, but I will go even further by suggesting that it is the round race on which such prodigious amount of time, talent, and attention should be focused on. Gary Marcus warned everyone into 2020 that scaling will run out. Grady Booch. Oh my God. This is not the new elite, bro. Oh, crap. Anyway, this is another leaks. But yeah, Grady Booch, right? Grady Booch. Again, he's the scientist, storyteller, and philosopher. I get it why a lot of this software engineers that when they want to, not only software engineer, whoever wants to go dive deep into their subject, right, of study, whether it's on the anatomy, medicine, law, technology, software, computer, mathematicians, hookers, whatever, is that, hey, somehow you will need to make sense to all of this complexity and mist. To cut the fluff, you need to create now a story that aligns to the nature as much as possible, right? So it might not sell a lot of newspaper, but in the long run, it will give you, it will align yourself with the reality of things, that you can operate and work and live a life along with this. So I honestly wish him the best. Oh my God. Oh my. Oh, you don't have idea. Wish him the best to all of this. But there is. Let me actually explore this video because I think this is quite important. Grady Booch, the evolution of software architecture, especially for this big companies that I mentioned here. Is this one?
Helping the federal government and helping contractors try to apply this new language in new ways. And this was the beginnings of the second golden age of software engineering, in which it was not so much the complexity of the algorithms, but it became a systems engineering problem.
Which is exactly where we are right now. It's not an algorithm, it's not a series of steps, it's not the complexity of all of the series of steps. Don't get me wrong, we need to actually explore that kind of stuff, which is something that I'm going to do on the next month by taking the course, the Introduction to Computer Science from Harvard, the CS15, and some more a more practical approach of data structure and algorithm. But in any case, here, Grady Booch.
Systems that were dealing with distributed systems that were very new at the time. And that was the essence of the Booch Method. It was the things I learned about helping organizations architect systems with these new kinds of domains and new kinds of languages.
Could you explain what the Booch Method is? I understand it has to do with object-oriented programming, but coming from you as the person who invented it, it would be nice to explain what it is and why it was important.
Well, let's go back to Plato.
Oh my God.
Talking about going way back. I wasn't around then, but I've read about him a little bit. There's this...
I wasn't around that, but I read about it.
Wonderful treatise he wrote, The Dialogue. I've read about him a little bit. There's this wonderful treatise he wrote, The Dialogue, in which there's a debate about how one should best look at the world. Should I look at it?
Here we go.
There's this wonderful treatise. I wasn't around then, but I've read about him a little bit.
But I read about it a little bit. You know, I'm taking notes all of this, and I'm taking all of this kind of inspiration. This is also a reason, making a quick pause here. The reason of why I'm doing all of this kind of stuff, taking notes, recording myself, because once you truly want to know, once you understand something, you will do that. Period, bro. Period. If you really need to do that kind of stuff, you will find a way. There is no how. There is no recipe. The recipe in itself will emerge from the need, the desperate need of knowing that stuff, if you truly want that, which is why we are right now in this video. So, please.
There's this wonderful treatise he wrote, The Dialogue, in which there's a debate about how one should best look at the world. Should I look at it as
Okay. So it comes from Plato, right? How should I best look at the world? That's quite interesting. How should I best look at the world?
As atoms?
Should I look at it as atoms? Or
should I look at it as processes.
Oh my God! It all starts with this. It all starts at how do we look, how do we observe? Oh shit! How do I look?
It as audit about how one should best look at the world.
Or how one should best look at the world. How one should best look at the world. The question is, best for what? You know, best for an outcome, best to produce, best to generate, best to replicate. If that is the end goal, all right. But that's why we need to define this kind of metrics here, in terms of the best. So I'm assuming right now, due to the lack of context and knowledge, that how one should best look at the world is based on Plato's, is through atoms, is a small unit of interactions, or through processes.
Should I look at it as atoms, or should I look at it as processes? Well, the first golden age of software engineering was more focused upon the processes, the algorithms. But
so the first golden age of computer
of software engineering was,
or the first era of software engineering was to look at the world as processes. So for example, we have now stuff in software computer, that's right. For example, things like threads and processes and scheduler, and how now you can switch off a process from a CPU so another process can run. It also is this is the fundamental of all of this.
more focused upon the processes, the algorithms. But there's a parallel way of looking at the world, and that's looking at it through the atoms. But there's a parallel way of looking at the world based upon the processes, the algorithms. But there's a parallel way of looking at the world, and that's looking at it through the atoms, if you will, the classes and objects within them. So yes, I was in.
Oh my God! So it makes a lot of sense that there is a parallel in the real world of how one should best look at the world is through processes or through atoms, and that's why now is the golden age, or the second golden age of software computer kicks in with objects and classes.
Influenced by abstract data type theory, by Plato, by a lot of other interesting philosophical things that were coming together at the time of looking at the world in fundamentally different ways. So the Booch Method was really trying to codify that. How could we decompose systems not based upon algorithms, but how do we decompose it based upon classes and objects? And again, that's where I was influenced by Liskov and Parnas and Dijkstra and Hoare and the like. Names that are probably unfamiliar to students these days, but they were representing the theoretical underpinnings of the first and second generation. The Booch Method was basically saying, hey, here's a new way of thinking about the world. And so it said, look not at algorithms, but look.
Here's a new thinking. Okay, here's a new way of thinking about the world.
And so it said, look not at algorithms, but look at combining data and processes, algorithms together in one thing, thereby classes. Now, we did some things right, we did some things wrong. I think the things we did right was classes make a lot of sense in terms of abstraction. Yeah. What we did wrong is we overemphasized the notion of inheritance. Inheritance was all about, let's save code because we can build generalizations and the like. That proved to not make a lot of sense because we ended up doing lots of disparate kinds of abstractions. That's okay. Fast forward to today, and people say, well, what difference does it make? And the answer is, it's part of the very atmosphere in which you breathe, and so you don't even think about it. You look at, Redis, and you may build things upon it, but, if you look at it, you're really dealing with a set of abstractions that Redis offers you And those abstractions are class-based. So they're baked into the way of thinking of those kinds of systems. So in short, the Booch method was, let's look at the world not through algorithms, but instead through objects and classes. The last thing I'll mention is one of the things the Booch system, the Booch method hinted at that really did not catch full form into the UML was looking at systems through multiple points of view. Now, we'll come back to that in a bit. Was looking at systems that really did not catch full form into the UML system the Booch method hinted at that really did not catch full form into the UML was looking at systems through multiple points of view. Now, we'll come back to that in a bit when I talk about Philippe Kruchten.
Okay.
So just so I understand, because myself and most of us listening will have started our careers long after the Booch method.
So the Booch method is to let's take a look now at the world through classes and not through processes. The Booch method is a method for object-oriented software development, and it is composed of an object modeling language, an iterative object-oriented development process, and a set of recommended practices, which is now is a method for object-oriented software development, and it is composed of an object modeling language, an iterative object-oriented development process, and a set of recommended practice. The method was authored by Grady Booch when he was working for Rational Software, acquired by IBM, published in 1992 and revised in 1994. It was widely used in software engineering for object-oriented analysis and design, and benefit from ample documentations and supported tools. The notation aspect of the Booch methodology was superseded by the unified model languages, Okay. So the notation aspect of Booch method methodology was superseded by a unified modeling language, which features graphical elements from the Booch method along with elements from the object modeling technique. From the object modeling techniques, in which it say, hey, OMT was developed as an approach to software development. The purpose of modeling, according to Ron Barr, are testing physical entities before building them, simulations, communication with customers, visualization, and reduction of complexity. This is the OMT state diagram. So this is now laying out the foundation of the theoretical foundation of this as a method to develop object-oriented systems and to support object-oriented programming. OMT describes object model or static structure of the systems. So, but in any case, we're looking now at this huge overview of the object-oriented programming in terms of how one can best look at the world is through processes or through atoms. And through processes is a way how the initial golden age of software computer, we have looked at things. However, there is a parallel in the way of how you look at the world through atoms, and that is now why the Booch method emerges. Let's take a look now at the world is through objects and classes, and therefore now develop this kind of applications on this. So this is great because even though there are a lot of companies out there, especially a startup company, they don't emphasize too much on this, or at least to create this particular UML model and all that kind of stuff. It was
invented for us. Classes, variables, inheritance, that's pretty common, pretty everyday things. But as I understand, it wasn't like that back then, right? So could you talk us through what the environment, the technology was like? So that what made the Booch method so new, interesting, or innovative?
Well, let me go even further back to the 1950s and show you a parallel story. There was a time in the growth of algorithmic programming languages where the idea of a subroutine was considered controversial. Why? Because doing a function call added at least 2 or 3 more instructions, which was computationally expensive. So even function calls and decomposing something into subroutines was viewed as an architectural aberration, and people opposed it because it was inefficient. Well, obviously, we think, well, that was stupid because we need it for our management of complexity. The same thing, I think, was true back in the days of early object orientation. I mean, people were doing object orientation in algorithmic languages because you'd have these things in COBOL called, common data areas. People would devise, here's all this common data. And as a matter of practice, but not language, you would say this data is used in this way by these algorithms and vice versa. In fact, going back to that project I mentioned to you at Vandenberg Air Force Base with those 32 computers, on the side of every one of those computers, every day, we'd see a printout of here is the common data pool. And so it was the abstractions right in your face because they changed. And so people were trying to do algorithmic or object-oriented decompositions, but the languages didn't support it. There was a need to do that kind of thing. And until the languages came into play, there was no way to bring those ideas together efficiently. And so, yes, the Booch method was very much a reaction to the forces upon building software-intensive systems to look at classes, trying to apply it with modern languages and building a methodology around it. Today, we take it for granted because our languages make it easy for us to do this.
It's just fascinating to think back how revolutionary it was and compare it to just how commonplace it is. And also to think about how things that we invent today and that are revolutionary in 20 years, people will be like, oh yeah, that's commonplace.
Yeah. Right, exactly.
One thing that you're known for, and you also mentioned you're associated with it, is UML. But can you share how this was created? What was the goal of it back then? Who were involved? And what was the need that it was solving at the time?
Right. So in 1982, 2 of my classmates from the Air Force Academy, Paul Levy and Mike Devlin. Paul had been a roommate of mine at the Air Force Academy. He was an economics major. Mike Devlin was a computer science major. Mike and I had a few classes together. The first time I ever met Mike was in an unarmed combat course, by the way. So not your typical thing you get at colleges, but hey, I was trained to be a warrior. So that's where I first met Mike, and I think he beat the stuffing out of me, if I'm not mistaken, in a pugil stick competition. But here I was at Vandenberg Air Force Base. Mike and Paul were up in the Bay Area. They were working at the satellite control facility, and I engaged with them because they had one of the first largest ADA projects that was going on. So I went up and helped consult with that project. The 2 of them also went to Stanford, and I swear there's something in the water at Stanford because they then connected with Art Rock and Hambrick and Quist, the 2 premier venture capitalists at the time.
Damn, son. Art Rock. Holy moly. Pack your lunch. Pack your lunch. Pack your lunch. Venture capital. Oh my God. Pack your lunch. And the other is Hambrick
and Quist.
Hambrick Conquest. Venture. Holy moly. How Arthur Rock kick-started Silicon Valley. Holy fuck. Behind the power law, how a forgotten venture capitalist kick-started Silicon Valley. An evening with a legendary 17 years old. Yeah. What the? This program may not be reproduced or distributed without the express permission of the science. Fair use.
To tonight's present semiconductors up to the integrated circuit. This is a $546,000 grant. Help with education. Do that. We're going to offer. We launch tonight.
Okay, this is
Had a customers man, which were brokers in those days, and
Holy moly.
he wrote to his father's broker.
Arthur Rock began his career as security analyst in New York
he turned it
City
over to me.
before joining the corporate
Can you-
finance
correct.
department of Hayden
And at
Stone
that point,
in
had you- were you
1957. He
exposed
worked
to
with the
computing?
Alfred Book College to
And,
raise
you
financing
had-
from
you had
Sherman
invested in a transistor
Fairchild
company already,
to
or-
found
We had
Fairchild
invested
Semiconductor.
in
The
a company
company
called
established
General
Silicon
Transistor,
Valley as the world center of innovation
which
in
made
integrated circuit.
germanium
Holy
transistors,
moly.
not silicon.
No, holy F, bro.
Those
Mr.
devices
Brock also invested
were
in a
used
held
primarily
early
in
stage
hearing aids.
board position at
I have
pioneer
a hearing
scientific
aid now
computing
that doesn't have a
company,
transistor.
Scientific Data System, at Teledyne,
at that
which
juncture,
grew into one
you
of the
still
most
had-
successful
you had no sense
technology
there was something
conglomerate in the
special or
history of
different
American
about
business,
computing than other
and an
industries.
Apple computer.
No.
He has contributed to the local community
It
by
was just-
supporting
it
the
was
San
a
Francisco
good
Museum of
business
Modern
deal,
Art,
and-
the San Francisco Opera,
Well,
and the
it was
California
it
Institute of
became obvious
Technology.
to
In
me,
2003, he donated
while
25 million to establish the
we were
Arthur
doing
Brock
the
Center
General Transistor
for
deal,
entrepreneurship
these
at
transistors
Harvard.
were going
was-
to be used in more than hearing aids. And
Holy moly, what the French
just
tells us
starting to be used
he was
in
Steve Jobs'
computers.
arch enemy.
And I
according
had
to
no
some
idea,
accounts.
of course, that computers would become
Arthur Rock me la pela.
become
I love it.
as widely
I love
used as they are today, and
So
for
in any
such
case,
scientific purposes. But it was obvious that
Anyway, Henrik's Conquest Communication Group. All right. Well, anyway, James Madison. Anyway, okay, yes.
The two premier venture capitalists at the time, Art Rock and Henrik Quist, were the key founders to Apple, and they also contributed to the funding of what became Rational Software. So in 82, contributed to Rock and Henrik Quist were the key founders to Apple, and they also
were the key founder to Apple.
Contributed
They also
to the
contributed
funding
to
of
the
what became
funding.
Rational Software. So in 82, Mike and Paul got together with me and said, let's start a company. And we did. It was a company called Rational Machines Incorporated, whose intent was to build a software development environment for this new coming Ada programming language. We saw that to be an opportunity in which we could make piles of money. And we built hardware at first because this was the time when, mini computers were becoming affordable. You had Sun coming into play here, but none of them were powerful enough to do the kinds of things that we were doing. So Mike designed a system. I helped build the methodology around using the system. It was a system called the R1000, and that was the dominant Ada system used around the world for Ada at the time. Well, around, would have been the early, jump ahead a decade now. Here we are, the mid-90s. And I was getting a little tired of doing that
Jump
kind of
ahead
stuff
in the
and branching
mid-80s.
out in other places. And I found that there was traction that I was getting from the Booch method into the commercial sector. I was giving a bunch of lectures at the time, and at one time there was a gentleman in the audience who asked a really insightful question. And afterwards, he and I met up. A guy by the name of Bjarne Strustrup. And it turns out Bjarne was working on a thing called C with classes, which was the predecessor
it's
to
a
C++.
language.
The two of us got together, we hit it off, we found that we were doing very similar things together. And in fact, it led to the two of us doing a lecture series around the United States where I got to know him quite well. And this was around the time he wrote his first book on C++. If you look at the first edition, you'll see he references a lot of my ideas, and that's when my book on object-oriented design came out, and I reference his work a lot too. So, the Booch method and C++ kind of grew up together. Well, I thought this was interesting, and I remember a particularly important meeting I had with Mike and Paul around the time. It was at the Red Carpet Club of United Airlines in Denver. And they met with me and said, hey, Grady, we're thinking of moving the company in the direction of embedded systems. And I said to them, well, good for you. I think that's a stupid idea because you're missing the commercial sector. Go off and have fun. I'm going to do different things. That gave them pause. And I think they realized, wait a minute, maybe there is something here in the commercial space. We were finding that we were having challenges continuing to grow the business in just the defense sector, which is what led them to that. And so they then made the decision, hey, let's take the Booch method and make it real. And thus was the beginnings of a system called ROSE, Rational Object-Oriented Software Engineering, our first tool. The first prototype, by the way, I wrote in Smalltalk. It was a wonderful system. I wish I'd kept the source code for that around, but I remember making changes to it just literal minutes before we did the first demo. And so that's where we sort of broke out from the defense sector into the commercial sector. And it was a big hit because that was the time when I think lots of others were recognizing object orientation was a good way of looking at the world, and C++ actually supported that. Well, that led to two things. Not just commercial success on our part, we began to make lots of money and we began acquiring other companies. And we started filling out the software engineering lifecycle.
Can you just tell us what Rational Software did, this commercial thing that was a hit?
Yep. So Rational Software, the ROSE, Rational Object-Oriented Software Engineering, was a personal productivity tool, if you will, that ran on an IBM PC. It also ran on, I think we eventually moved it to a number of other devices. It ran under Windows in the first one, that basically allowed you to draw UML diagrams, not UML, but Booch diagrams, so that you could then reason about and think about your design. We did a little bit of code generation, but really it was just a design tool to help organizations think about their designs. And people use it quite well to document and specify and build their systems. Now, we started making lots of money off of it, and so we started acquiring companies. We bought a requirements company. Ed Jordan came to me and said, go look at these folks. We did. We bought a small company out of Cambridge called Pure Atria, which was led by a gentleman by the name of Reed Hastings. Reed came to us, and we bought his company, and he said,
and we're talking about the founder of Netflix, right?
Yes. So we bought his
Small
company.
world.
Yeah, Reed realized he's a lousy CEO, and so he took his money, hang out around for a few years, figuring out what he was going to do, and actually that was a lot of the seed money that helped form Netflix. It is a small world in that regard. So at that time, at the peak of what we were doing, and so we started acquiring companies. We bought a activity tool, if you will, that ran on an IBM PC. It also ran on, I think we eventually moved it to a number of other devices. It ran under Windows in the first one, that basically allowed you to draw UML diagrams, not UML, but Booch diagrams, so that you could then reason about and think about your design. We did a little bit of code generation, but really it was just a design tool to help organizations think about their designs. And people use it quite well to document and specify and build their systems. Now, we started making lots of money off of it, and so we started acquiring companies. We bought a requirements company. Ed Jordan came to me and said, go look at these folks. We did. We bought a small company out of Cambridge called Pure Atria, which was led by a gentleman by the name of Reed Hastings. Reed came to us, and we bought his company, and he said,
and we're talking about the founder of Netflix, right?
Yes. So we bought his
Small
company.
world.
Yeah, Reed realized he's a lousy CEO, and so he took his money, hang out around for a few years, figuring out what he was going to do, and actually that was a lot of the seed money that helped form Netflix. It is a small world in that regard. So at that time, at the peak of what we were doing, by the late 1990s, IBM Rational was sort of dominating the space of software engineering because we had tools across every part of the development lifecycle. And this is where the ideas of incremental and iterative software development came into play. Long before today what we call continuous integration and continuous deployment, we were already doing that with the Rational machine and our tools. We had pioneered those ideas because we had built incremental compilation tools and the like. So here we were in the 90s, and we had a whole set of tool sets around this. But because this was clearly gaining traction in the marketplace, we weren't the only ones. And we were seeing the rise of hundreds, if not a few thousand companies that were beginning to try to do object-oriented kinds of things. And this was the beginnings of the second golden age of software engineering, where you had Pete Code and Konstantin back again, and Jordan again, and Martin. We had Ivar Jakobsen and Jim Rombaugh. And so it was a very vibrant time where organizations were trying to say, gosh, we've got these great tools, we've got the ARPANET, we've got personal computers, how do we build software for it? So the presenting problem was, in software, what is the best way to design systems using this very, very robust, very powerful set of tools we have at our hands? And so, Rational being in a very interesting space, we said, we're kind of dominating the market, let's keep going here. So we hired Jim Rumbaugh, and the task Jim and I had was to combine his methodology, OMT, object management technique, with mine. We were sort of the two leading ones at the time. And then we bought Ivar Jakobsen's company, because both Jim and I were using what was the idea of use cases. Again, talk about something that's part of the atmosphere. Use cases are just something you think about, but they were new at the time in the 90s. They were an idea invented by Ivar in his work primarily at Ericsson. And so we were working together with Ivar on building software for base stations for the burgeoning cellular telephone networks, which were a thing back at the time as well too. So here we have the three of us who were brought together by Rational, and our task was, let's unify our methods. Now, you could never have found three very different people. I'm pretty amazed that we didn't end up with one of us in the hospital and one of us in jail. We were so very different. And I won't go into further detail on that, except to say that I'm very proud of what we created. And from that was born the UML. So we decided, this is not just ours, we need to make it something that the whole world could use. So we made the decision to release it into the object management group, and that was born UML 1.0. I sort of drove most of that, working with Jim and Ivar. I wrote the primary document for it. Obviously, it was the three of us working together. I don't want to, I want to give them complete credit, believe me. But after UML 1.0, I was emotionally exhausted and wanted to go off and do new things. So I kind of walked away from it at the time. I want to pause and mention one other person who was important here, actually two other people. The first was Philippe Kruchten. So we realized that our work was so big, we couldn't just do the methodology and the notation. So Jim, Ivar, and I worked on the notation. That was the UML. And Philippe worked primarily with some of Ivar's people on the methodology, and thus was born the Rational Unified process. Notice the emphasis upon unified. Philippe brought to the table the very important idea that we've begun to see hints at with the Booch method, and that is looking at the world through multiple points of view. Philippe has this idea of the 4+1 view model, which he grew from his work with building the Canadian Air Traffic Control System. Again, a very
Canadian Air Traffic Control System. Again, a very complex
distributed system. Those ideas were eventually made manifest in an IEEE, IEC, IOC standard for
completely, man. It's the ISC. Oh my God. ISO, ISC
42020 on architectural description, which basically says if you're looking at an architecture, you have to look at it from multiple points of view.
Exactly. If you're looking at architecture and how the things are built, you need to look at it from the different perspective, or from multiple point of view.
Use cases, logical view, process view, implementation view, and deployment view. And that's a very important and profound piece. The other thing that came into play, another person that came into play.
Why this is important, you might wonder. Fair use, after all, fair use, is because we're about to build now this simple plant watering app, right? In React Native. And despite that we know how all of these core features works, all right? In terms of, hey, the React Native in itself, right? So what is the value proposition? What is the inner mechanism? What is the React or the rendering or the inner tools behind the scenes, for example, like React and React Native that is using now a mechanism to actually render this kind of elements platform specific, such as Fabric, and how now Fabric works behind the scenes, that it has these three different phases, the render, the commit, and the mount. And then this particular pipeline can happen in different threads. So in React Native, you have now these two threads that is the main thread or the UI threads where it can only manipulate its host view, and the JavaScript threads where the React logic and the visualizations and the layout calculation happens. So all of these foundations, as well as the most common directive that you can use in React Native, such as view, text, the navigations types, using now Expo, such as stack, tabs, and models, and how you can link this with nested animations, and also the text input, the scroll view, the flat list. What is the subtle difference between the scroll view and the flat list? And to enhance now the user experience by adding now, for example, is a touchable area to provide the user experience, or to provide so the users can now actually press or have a more surface area so it can interact with the elements. And how we for that implement now a toggle to do that. Use the layout to the layout animation, at least to animate is this UI components, and also the way of storing or the persistent state of your application, and provide now custom animation using, for example, React Animates. And for device interactions, such as haptics and push in or push notifications and in-app notifications, and then how you can combine that to create now some applications like a scheduler and use now Confetti for that. So the idea of this, being able to describe these foundations from the previous course of React Native, is just to make sense of now how we're going to deploy these apps, not only in this hybrid way of mobile apps, all right, using React Native, but also for any other kind of development, whether it's web or mobile. So because of this, and that at the end of the day, the reason of why exploring now, how can we publish our apps in React Native, in iOS and Android, using Expo, is something that by exploring the ideas of the Booch Method or the UML, which is useful for complex systems. If you can imagine the air traffic systems, that is mind-blowing, bro. That is wild. So for example, air traffic here, right? There is a like flight radar. Just as it, I don't think it show now the flight radar. Oh, it does. Holy moly! It show that in real time, and it is blazing fast. By the way, you can see this is blazing fast. This is blazing fast. So imagine that you are now have to deal with this kind of systems, with all of these data sets or all of these airplanes that have their own pilot, their own staff, pilots. I don't know how you say azafata in Spanish, azafata, English, stewardess. What the fuck? Hottest?
Stewardess.
Stewardess. This is British. Stewardess. 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 Stewardess Hostess.
hostess,
Hostess. Hostess. Okay, hostess. The stewardess, right? And of course the people in there. So the amount of complexity that you need to handle this, it leads you to, well, people that are handling this kind of problems come up with some sort of solution for that.
The other thing, employment view, which based standard.
This is now a standard. ISO ISC. God damn.
420020.
422. It's like 4220. I think it's another one. 00. My bad. Is this one?
On architectural description.
On architectural description. Okay. Architectural. Oh, is this one? ISO ISC IEEE. Holy hell. On architectural processes. On architectural processes. This document establishes a set of process description for governance of management of a collection of architecture and architecting of entities. This document also establishes an enablement process description that provides support to this other architecture process. Again, this is going too deep into this topic, but it's important at least to know this. Software system and enterprise architecture processes, right? Which is quite interesting. Oh my God, what the? Yeah, which is quite interesting. But again, coming back to what is,
which basically says if you're looking at an architecture, you have to look at it from multiple points of view: use cases, logical view, process view, implementation view, and deployment view. And
but he mentions
logical
something
view,
important
process
here.
view, implementation.
Exactly, is that view, use cases, logical view, process, implementation,
view, and deployment
view.
And that's a very important and profound piece. The other thing that came into play, another person that came into play, was Walker Royce. Now, Walker's an interesting guy. You talk about a small world. His father, Win Royce, who I had the pleasure of working with when he was at Lockheed at the time, Win Royce was the gentleman who wrote the paper on waterfall life cycles, and his son was basically working on spiral models in the Booch method. Win was misunderstood because he was not endorsing waterfall methods. He said that's a stupid idea. In fact, look at Parnas's paper, A Rational Design Process, Why and How to Fake It. It's from that the Rational Software name came out of, by the way, which says at one level it looks like waterfall, inside no, it's what today we would call agile. So here we are what, the late 90s, early 2000. UML 1.0 was in the bag, and that was the life of Grady at the time.
Hey developers, we've all been there. It's 3 a.m. You scramble pinpoint a differential diagram with
That
just
was
the morning. It was named a fear that the goal of UML was to describe a system. So when I think back to college with UML, we have the different boxes of different classes. We have the arrows between them. They describe relationships depending on the type of the arrow is. And when you look at this whole diagram, you get a sense of the structure of the software you're building.
Yes. So if you look at the very first line of the UML 1.0 standard, I believe it says something to the effect, the UML is a visual language intended to reason about, visualize, specify, and document the artifacts of a software-intensive system. It says nothing about it being a programming language in the artifacts of a software-intensive system. Visualize, specify, and document.
Visualize, specialize, and document, which is exactly what I'm actually dealing with this, is to visualize, specialize, and document
the artifacts of a software-intensive.
The artifacts of a software-intense. Oh, the artifact, the production, the outcome from this, the artifacts of a software-intense
It says
systems.
There's nothing about it being a programming language. In fact, I voraciously pushed back against that. It was a language meant to think about and reason about a system, to think about the world in object-oriented ways, particularly in ways that you looked at it through multiple points of view. DevOps today, by the way, is simply an amalgamation of deployment and implementation views. But we didn't call it back that way then. We looked at it from those kinds of views. And that's really where UML 1.0 was. It was meant to be, how do I think about these things? How do I reason about them? And I always intended for, you'd write a UML diagram and you'd throw most of them away. Now, unfortunately, many people didn't do that. And in the move from UML 1.0 to 2.0, there was a faction of individuals and companies who said, no, we want to make the UML very precise. We want to turn it into a programming language. And that was, I think, a profound mistake. I never intended the UML to be a programming language, but the net result of that was to make the UML much more complex, much larger. And the emphasis then was upon not using it to reason, but to generate code and to reverse engineer. Now, the reverse engineering I can get, that makes a lot of sense, but turning into a programming language was a mistake. And I think that began the decline of the UML because people were using it in the wrong ways. At its peak, the UML probably had a 20 to 30% penetration in the marketplace, which is pretty cool if you think about it. And so I'm proud of looking at the systems in which it was used, but most of all, I'm proud of the fact that it helped people think of building software in different ways.
So when you say that at peak it had 20 to 30% usage, does this mean that about 20 to 30% of commercial developers were using it at the time? And what time was this? Around what time?
Yeah. Exactly. When UML
Rabbit,
is no longer
MQ, or
industry,
whatever, or Redis, or whatever I need, the architectural decisions have been made for you. So a lot of the activities of contemporary architects is simply taking very large frameworks and components and weaving them together, which is a very noble and wonderful thing to do. They also represent systems like Meta and done as particular. They have grown their architecture and system over a few decades now, and the stuff they're building on top of it is largely evolving and building upon those APIs, which does not require the deeper kinds of architectural thinking. So I use this, let me give you an image here of a 3-axis system. Along one axis, you have levels of ceremony. If I'm a startup, then it's just my other people's money and no one else's. And heck, I can write disposable software, and if I fail, I'll just go find another venture capitalist. Of course, I'm not going to worry about any kinds of degree of ceremony, because just build it. Go hire some brilliant people and make it happen.
Exactly.
That's wonderful.
That's wonderful.
On the other hand, if let's say I'm doing something like, building the next generation intercontinental ballistic missile system, which uses about $500 billion, you bet you're going to use more ceremony because you have to have degrees of accountability. So that's one axis. The next axis is that of risk. So if I build a system and says, oh, if I fail, so-and-so's not going to find their grinder match. Big deal. On the other hand, if I fail and somebody dies, that's a problem. And you're going to use a more disciplined architecture. The third axis is that of complexity. If I build a system that people have done again and again, then heck, I don't need anything. Heavens, this is where prompt engineering comes into play. I go build an app just by building prompts because we built these things. I don't need no stinking UML. Don't need anything. Heavens, this is where prompt engineering comes into play. I go build an app just by building a more disciplined architecture. Mm-hmm. The third axis is that of complexity. If I build a system that people have done again and again, then heck, I don't need anything. Heavens, this is where prompt engineering comes into play. I go build an app just by building prompts because we built these things. I don't need no stinking UML for that thing. On the other hand, if I'm building something that I've never built before, let's say I'm building not an LLM, but I'm building a constellation of LLMs work together, and I want to weave them together with non-neural systems, then you begin to think about architecture, and that's where the UML comes into play. There's a sweet spot for a tremendous amount of software development going into place that doesn't need the UML and does not need any kind of thing like that. But on the other hand, you go a little further out in that 3 dimensions, and yes, there are people all over the place using UML. I mentioned the James Webb Space Telescope.
That's interesting. The 3 space, according to James Booch, of accountability, risk, and novelty. You may wonder that. Accountability, risk, and novelty. So in the accountability is that, hey, is this system that I'm building is, let's just to hire people here and then just build the stuff. Good, you don't require ceremony. Again, but if you're building now something that it will impact or something that needs to be accountable with. So, for example, some interballistic missiles. Then you, of course, require some architectural decision here. You require more ceremony here. On the other hand, is the risk. Let's say if I'm building as an app that, I don't know, doesn't impact too much on the end user. So, for example, like software applications, then you don't need to go with that. However, if, for example, now it's put people's lives at risk, then of course you need now a more disciplined approach to, or a more disciplined architecture here. And the other is the novelty. If these things that I'm gonna build has been built before, there is no need to record that kind of stuff because all of this has been already recorded or documented. However, if I am building something new for that, for example, if I'm telling a prompt to generate now code that is something that, let's say, React code, so I'm quite familiar with that, so no problem with. But now if I want to build is a constellations of LLMs that are going to connect each other's with non-neuronal networks, then it becomes now this novelty. Then now, of course, it becomes a norm of UML. But this is quite interesting, this axis that he mentioned.
Work with financial companies who are doing that, where they're in the James dimensions. And yes, there are people all over the place using UML. I mentioned the James Webb Space Telescope. I still work with financial companies who are doing that, where the risk, the complexity, the ceremony is sufficiently
the risk, the complexity, and the ceremony
high that it demands a bit more formalism.
So do I understand it correctly that you're saying that software architecture has changed from the 90s and 2000 when systems were new, architectures were new, software architecture was still a lot more novel? And if we look at venture-funded startups and big tech today, what we see is, one, they're just not as risky. If they fail, big deal. And then two is we can use a lot more software that's out there and been architected. And, we can, for example, use Redis as a cache, and it is there, it works. We don't need to think too much about it. And then the third is that there's a lot of startups who just don't need ceremony. Basically, they don't need audits. They don't need formality. They can just go like, all right, let's just do it however we want to. We don't need that kind of auditability. Do I understand that these are the changes that are in play with software architecture? And is this why like some of these formal methods are just not as popular with startups and scale-ups?
Yes. In fact, I think it goes to the root of the economics of software development. Let's go back to the first age of software, first golden age. The machines were far more expensive than the humans. Mm-hmm. And so it required one to do some thinking before I even got to the machine, because machine time was very, very expensive for me. And so, yes, algorithmic decomposition, structured analysis, design techniques made a lot of sense because we needed that kind of optimization. If you move to contemporary times, computational resources are like water to a fish.
Yeah, like
they're
water to a
available
fish.
to anybody. I've got on my desk behind me, I've got my own personal cloud of 4 NVIDIA single board computers, which has more processing power that existed in the world in the 1970s. And that's pretty amazing. That's a few $1,000s there. And so the economics have changed vastly such that you don't need to think about it so much because heck, it becomes disposable. AI I think is also changing that because it allows me to build things where I don't even have to think about design. Heck, I don't even have to think about software. I just prompt it for those things to build something and
Fair
one-offs.
use.
And once I'm done, I throw it away. So in that sense, it comes back to the economics, but there will continue to remain a class of software that's new, unique, breaking new ground that still requires that kind of architectural thinking.
And it's interesting because just recently I read how Amazon is using formal methods for AWS S3. They're publishing a blog post detailing like how they're doing it. And they're doing this to catch those really edge cases that only happen in 1 in a billion, 1 in a trillion. But at their scale, this is a regularly reoccurring event. And I found it fascinating how some of these methods are making their way back.
Yeah.
How this is 1 in a catch detailing like how they're doing it. And they're doing this to catch using...
Wait, what?
Just recently I read how Amazon is using formal methods for AWS S3. They're publishing a blog post detailing
Formal methods. Formal methods. Oh, in software engineering. Oh, here we go. It's because it's a scalability, bro. Formal methods in software engineering. Here we go. You know, it's scalability problems, bro. Scalability problems, bro. Rigorous techniques for specification, developing, analysis, and verification of software and hardware systems. Of course, they need to set this thing up like that. Automated theorem proven, model checking and abstraction implementations. For sequential software, example of the formal method include the B methods, or the Booch method, I think it is. The B method is a method of software development based on B, a tool supported formal method based on abstract machines notations, using in development of computer software. B was originally developed in 1980s by Jean-Raymond Abriel in France and the UK. B is related to the C notation, also originally Abriel. And how do you install this? The GUI maintains and runs primarily on Linux, Mac, and OS and Solaris. B Toolkit. This is software. B Toolkit, Atelier, Rooting, and BHDLA. Holy moly. It's a collection of programming tools supported to use B tools. It's a set of theory-based mathematical interpreter. B Toolkit. Holy crap. B Toolkit is a toolkit supporting. Holy moly! Again, B Toolkit. All right. Anyway, yes.
like how they're doing it. And they're doing this to catch those really edge cases that only happen in 1 in a billion, 1 in a trillion. But at their scale, this is a regularly reoccurring event. And I found it fascinating how some of these methods are making their way back.
Yeah. Well, let Let me set aside formal methods in a moment, because it turns out that's a different topic for which I have some experience and opinions.
Fair
But
use.
go back to Amazon, you go to their websites and they have a whole language around architecture. Microsoft does as well too around Azure. It's the way I describe an architecture in Amazon. It's those, their blocky diagrams. It says, hey, I'm going to build this kind of thing, and here's my particular notation for
blocky
it.
guy.
And furthermore, here there are some examples. So even Amazon and Microsoft have recognized that architecture plays a role, but there are enough times people have done these kinds of things. It says, oh, you want to build this kind of system, then you want to use these services. In fact, here are some examples for it you can find on our website. So without them really acknowledging it, Amazon and Microsoft view architecture as still important. But there are enough patterns that one doesn't have to go through the process of rediscovering those, because I can build those things. And this is a representation of the maturation of our business. We move from algorithms, which everyone can use, to design patterns, to now architectural patterns, which Amazon and Microsoft have codified themselves. So let me switch over now to formal methods. Formal methods have always been a thing. However, formal methods, in my experience, have been a niche part of every software-intensive systems, because formal methods only go so far
Fair
in
use.
what domains they can cover. And so you'll see, is what your example described, Microsoft began using formal methods in their drivers to validate the correctness of their things.
Their
But they
hardware
didn't-
driver.
With their hardware, exactly, yeah. And that was an important move forward. I've been with projects that use things like, I've got this system in which people might die, let's run a formal analysis upon it. The thing is, though, that those formal methods don't deal with real world things, because they don't deal with space and time. They deal with functionality. So I have always found formal methods to be of use, but only for parts of a system and never as drivers of the architecture itself.
Speaking of software architecture, these days the role software architect is not really popular anymore, at least at the likes of startups and big tech. Instead, we do have architects, but they're increasingly called staff engineer, principal engineer, distinguished engineer. The architecture is, and they do still do architecture, but there's a different focus on it. Now, you were there when software architecture was created, when the first software architects were created as a role. Can you tell us how you've seen this role be created and then evolved throughout the decades?
So two things influenced my understanding of the space. First is, I didn't really call myself an architect, but I helped people design the systems they were building.
Exactly.
I was heavily influenced
Because
by a
at the end
dear
of the day,
friend of
exactly.
mine, Mary Shaw. She's a professor at Carnegie Mellon. I think she won the National Medal of Honor under Obama, if I'm not mistaken. And she wrote this really profound book called Software Architecture, in which she began the first exposition of architectural patterns. Mary's just a delightful human being. And that's when I began to understand the formalizations of what architecture could be. And the other thing that influenced me was architecture from other domains, particularly civil engineering and the like. And
Fair
there's-
use.
in the defense world, there's also, shipbuilding architecture and airplane architecture and the like. So the term architecture is one that's very well respected outside the software engineering world. Ignore the title for a moment and let's go back to first principles. What is it at all? And you've probably heard me say this: all architecture is design, but not all design is architecture. Architecture represents the set of significant design decisions that shape the form and function of a system, where significant is measured by cost of change. So software architecture, an architect has this horrible emotional baggage around it. So think of it as, it's all about making decisions. What are the decisions that shape my system?
Exactly.
As an architect, that's what I'm doing. As the project manager or whatever, I'm also
PM,
about making
PO.
decisions. But one subtle difference is that it's no longer just the decisions about the shape of the software, but it's the shape of the system itself, where it embodies itself in the physical world, where the other systems and humans themselves as well. That's what it is. It's all about decision process.
And have you seen this role change Did you see a golden age of companies where they were employing software architects that were empowering them to churn out design? I'm seeing a bit less of this. I'm curious, are you seeing something similar? Is this just a bubble that we're seeing just because you seems you're embedded in a lot of different companies?
There's another soundbite I'll give you, which is that the entire history of software engineering is one of rising levels of abstraction. So what we're seeing here is the rise of another level of abstractions, which gives us all these extraordinarily powerful frameworks from which I can build systems, in which, as I alluded to, the architectural decisions that were front and center for us back then are now embodied in these. So now it becomes a decision: what cloud service do I use? What messaging system do I use? What platform do I use? That's the decision, which has a lot of economic decisions and not just software kinds of decisions associated with it. So I think the role of the architect, in effect, has changed, because now I'm dealing with systemic problems, not just software problems.
And have you heard about the role called solutions architect?
This is interesting because, especially for the architects, for those who truly wants to be architect, right? Is that, hey, you're not going to deal with software problems, but also with systemic problems. Again, I know this is go beyond the scope of today's video and all that kind of stuff, but it's just to have a wide perspective, especially when we're writing this kind of applications, so it'll make a lot of sense to build this kind of apps. So there's a huge ton of concept that we have absorbed right now, all right? And it is up to us to define and to say, hey, you know what? Jesus. All right.
I think it was created maybe 10 years ago.
Yeah.
And it's about people who are doing cloud architecture. It's fascinating. It's a role specific to the cloud. Right. And as you said, they make economic decisions.
Yeah.
What services do I use? Do I use AWS, GCP? If I use AWS, do I use EC2 or do I use another service?
Yeah, and that's why it's a systemic issue. You generally, if you're a startup, you're going to hire somebody who's done that before, who knows where the skeletons are buried, who knows, what the costs of these things are, and so that you'll hire those kind of folks because they'll accelerate you because they've made those decisions and they sort of know in the shape of what you're building now what decisions next make sense, and they are systemic decisions because they have economic and long-term associated consequences to them.
One thing when it comes up with software architecture is migrations. I do notice that most large companies are being hurt by long-running migrations. And these migrations usually happen thanks to software architecture changing, for example, from going from monolith to microservices, or changing technologies, for example, going from Node to Go, or upgrading major versions of frameworks, for example, one version of Angular to the other one. How do you think software architecture and migrations are connected? And why do you think software migrations are just so darn hard and they don't seem to be going away?
They are. Migrations will plague us until the heat death of the cosmos, I believe, because
really
there's
hard.
you're always building economically viable software, but then the technology is changing out from under you that compels you to consider migrating. Consider the migration from monoliths from the 60s, 70s, 80s, till all of a sudden economically we had mini computers and now distributed systems. You're still not going to use an iPhone and put everything up in a mainframe, but those changes compel you to consider an architecture that better balances where the processing takes place. If all of a sudden I can begin to do edge inferencing on my devices, that's going to be something that's going to change architectures as well. So there are always these changes, both in the hardware as well as societal changes, if you will, that impact the structure of my systems that are the forces that compel me to do this migration. But why is it hard? Well, another soundbite I'll give you is that the code is the truth, but the code is not the whole truth. There is so much that is outside of the code that represents design decisions, their rationale, why I chose this versus why I didn't choose that, subtle things as to why did I name things this way because of its impact that is long misunderstood. And so while the code may be the truth, the problem with moving migrations is that you lose, there's a loss of information, and it's difficult to try to recreate those design decisions just from the code. The people who wrote that initial code you're trying to move, they may have, they probably cashed out, or they've done.
Which is exactly what happens here when you look at old code bases. They probably just want to cash that out, or they probably die, which is real. And anytime you get into a particular code base and to understand, to look at how all of this kind of stuff works, is just to see that those kind of decisions that they made back then is just a way of how now they solve those
died or some combination of. And so you don't really know why those decisions were made, and so you're working a little bit in the dark.
Yeah, you're mentioning people have died, and I don't think we usually think about that, but I guess when you're thinking about systems that are 40, 50 years old, that is the reality of some of them.
What will the Linux kernel look like when Linus eventually retires? So how will it drift? Because he has provided a firm and much needed hand upon the conceptual integrity of that system. And that's what the chief decider makes. He or she is the one that provides that conceptual integrity. And when that person is gone, then you naturally see drift, and that's inevitable. It's entropy. All software exhibits some degrees of entropy. Without adding that kind of force to it.
One thing that is very relevant today in terms of technologies and architecture is AI. This technology is here. It's revolutionary. It is disruptive.
First, I think, was just the realization that I could build distributed systems as opposed to putting all my processing on one. That was a change that rattled everything in the way we built systems. So at the point in time that all of a sudden I could have a network of mini computers, and then eventually that carried on to microcomputers and devices at the edge, like phones themselves. But that transition in the growth of mini computers was seismic. that I don't think people understood the full implications of until much later, because it required us to rethink the way that we put systems together. So we saw there the rise of a great degree of uncertainty because we didn't know how to build these systems. I have messaging across them. Do I use RPC? Do I use something else? What do I use to communicate? Do I use
Fair
shared
use.
memory? And so there was this period of exploration that we didn't know about until it finally we realized, oh, these are the common ways that work.
And can you remind me around what time this was? Was this around the 80s? Was it around the 90s?
There was the late 70s, because here you had, well, let's go back way in history. There was the thing called, gosh, what's the name of it? I mean, I'm drawing a bit of a blank here, but
I'm drawing
we
a
first,
bit of a
here we
blank
are in the
here.
late 60s, early 70s, in which mainframes were roaming the earth. But even then, it was a realization that these machines were sometimes being underutilized.
Roaming.
And so there was born the formation of the first time-sharing systems. The next thing that happened around the same time were systems such as Whirlwind, which came out of the Lincoln
roaming.
Laboratories, which was beginning to take
wandering.
machines
Roaming.
and touch them to the real world. So all of a sudden now you had real-time computing systems such as Whirlwind,
Roaming.
which came out of the formations were sometime in the earth. But even then, it was a realization that these machines were sometimes being underutilized. And so there was born the formation of the first time-sharing systems. The next thing that happened around the same time were systems such as Whirlwind, which came out of the Lincoln Laboratories, which was beginning to take machines and touch them to the real world. So all of a sudden now you had real-time computing. So you had this confluence of two very interesting things. You had large machines in which we were beginning to develop time-sharing kinds of operating systems, and then machines off to the side that were touching the real world. These came together in really the rise of mini computers, particular Digital Equipment Corporation and the like, where miniaturization, which frankly came about because of the investment the Department of Defense was making in semiconductors, making it economically interesting to have a computer that could sit on your desktop that one or two people could use full time. So it took kind of the ideas of the embodiment of things like Whirlwind, and then the distributed systems we were people building. Now all of a sudden I could take these things and I could start building them together. And that's what was happening in the mid to late 70s, that we saw the rise of those distributed systems. There was one last thing. There was the rise of client server systems where you saw dumb terminals. That's what IBM was doing at the time, the green screens, talking to mainframes. But the rise of those new machines meant I could move some of the processing off to the edge as opposed to leaving it to the monolith. So those are the forces that led us to rethinking about systems.
So do I understand correctly that programmers at the time, they were used to working on these large computers and distributed computing came in?
Absolutely.
And it just completely changed the dynamics. So
Fair
youngsters
use.
came in, they started to embrace this distributed computing, but
Yes.
existing programmers, they kind of stick to what they knew, what was efficient on the mainframe. Was that what it was like?
It was. And then when you had things like TCP/IP and HTML and all those things around it, all of a sudden we now had a vocabulary. We now had mechanisms that we could bind these things together. So I would not say that LLMs are as pervasively as important as the rise of distributed systems, but there's a parallel to it. The second thing I'd say that is sort of
Exactly. There's a parallel to it with people that know. Oh, crap. There's a okay. There's a parallel of. This is quite interesting in terms of describing now the AI, the disrupt exchange, and major leaps in software development, especially when back in the 60s and in the 60s and the 70s, where people were now have this idea that when mainframes and start to roaming the world, we have now this idea that they have this computational power here, idle. So that's what they define and they create now this control system, but this
touch
is
them to the real world. So desktop, and that's what the rise of those new machines meant. I could move some of the processing off to the edge as opposed to leaving it
exactly.
in the monolith. So those are the forces that led us to rethinking about systems.
We're used to
Absolutely.
and these
Those
So
like
is
the
this
building them
time-based?
together system of
Is this
who's
time-based
interested in the
computing?
departmentalization, which instead on your desk embodiment the distributed together systems.
So do I understand correctly that programmers at the time they were used to came in, they started to embrace this
Often now it took kind of the ideas of the embodiment of things like Whirlwind, and then the distributed systems we were people building. Now all of a sudden I could take these things and I could start building them together, and that's what was happening in the mid
but when
which
they met,
particular
when
these
he mentioned
stories of
about
time
this,
were systems to take machines and touch them to the real world. So all of a sudden now you had real-time computing. So you had machines
exactly, but this
which
time
came out of
computer.
the realization that these machines were sometimes being underutilized, and so there was born
They were
the
idle.
formation of the first time-sharing systems.
Time-sharing systems like that. So,
The next thing that happened around the same time were systems such as Whirlwind, which came out of the Lincoln Laboratories, the rise of distributed systems, but there's a parallel to it. The second thing I'd say that is sort of similar to that is the rise of GPUs, which came from the gaming industry, because there they
the dynamic.
last thing
he
there was the
mentioned-
rise of client server systems.
Exactly. Is with this new advance, with this new disruption, it come out with some sort of vocabulary, a vocabulary that is now allowing us to, a vocabulary that allowing us to is define what is coming next. So this is the thing that we are used to this, used to build, and now we are going
Where you saw
to
games,
do
the
this.
edge, as opposed to
Do I understand correctly that programmers at the time they were used to working on these large
These
computers and
mainframes.
distributed computing came in
absolutely.
and it just completely changed the dynamics. So youngsters came in, they started to embrace this distributed computing, but
Yes.
existing programmers, they kind of stick to what they knew, what was efficient on the mainframe. Was that what it was like?
It was. And then when you had things like TCP/IP and HTML and all those things around it, all of a sudden we now had a vocabulary. We now had mechanisms that we could bind these things together. So I would not say that LLMs are as pervasively as important as the rise of distributed systems, but there's a parallel to it. The second thing I'd say that is sort of similar to that is the rise of GPUs, which came from the gaming industry, because there they were solving a very different problem. How do I deal with more photorealistic things in my games? And we realized it's all matrix multiplications, and so NVIDIA began to move into that marketplace, and we had the rise of GPUs, which dominated that space. And it wasn't until Andrew Ng came and said, wait a minute, those GPUs used for gaming use the same kind of mathematics as do our GPUs used for gaming. Until Andrew Ng came and said, wait a minute, those...
And I think I know you, Andrew Nin. Oh. Holy moly.
Those GPUs used for gaming use the same kind of mathematics as do our deep learning kind of things, and poof, all of a sudden we had this perfect storm of lots of data, powerful hardware, and the rise of interesting algorithms,
Fair use.
backpropagation and the like. So it was a perfect storm. So yes, this is an exciting time. There's no doubt that large language models are interesting, but we must be careful, and we'll go into that in a moment.
So let's go into that. I'd love to hear your candid thoughts about LLMs, their applicability, the innovation, and the trade-offs that they come with.
Well, so to set the stage before people worry that I'm just pontificating about things I know nothing about, I alluded to at the very beginning that, and here I was 12, 14, whatever, I was interested in what was burgeoning, becoming AI at the time. That has always kind of stuck with me. And in, what would it have been? I've always, pursued and interested in that space. And it wasn't until IBM drew me back to it around the time of Watson that I began to make it a full-time thing. System based on Watson technology. But there was something missing out of it. And the team came to me and said, Grady, would you please help us out? So I did. I helped improve the architecture. We actually installed it in a few Hilton hotels. But as it turns out, just down the road from that team was the Johnson Space Center. And so we began to be involved with them. And I thought, this is all great because I can get back to my space roots. So they had a system called the Robonaut 2, which was a humanoid robot that at the time was on the International Space Station. A beautiful piece of engineering. And NASA was exploring the idea of human robotic interactions for the mission to Mars. So the group of us sat down and said, what would be an interesting design problem for us to explore that would propel us to look at hard problems? Because we want to do hard things. And we realized, and I built a neurosymbolic architecture, a company out of New Zealand. And again, being a fellow, they didn't fire me. So I continued in that. Going to be impolite, I will say they allow us to build at global scale bullshit generators.
Yeah, this is my intuition as well. And well,
because they are clearly, they are stochastic parrots. They do not reason, they do not understand, but they do produce some very coherent results because they allow us to navigate a latent space that has been made very complex through training it through the corpus of the internet. So that, I think, is back to the perfect storm. We have large language models based upon data and the algorithms and the hardware that allow us to build these coherent kinds of things. But again, we have to be careful. Gary Marcus and I have been voracious and consistent critics of Sam and others who are saying we're just on the cusp of AGI. Well, I think that diminishes the elegance of what AGI actually is within our humans. It diminishes what the beauty of what our human intelligence is. And frankly, we're not going to get there by scaling. We've already seen we're hitting limitations upon it. Elon, whom I've gotten into as well on the internet a number of times on his particular views of the world on AGI, he's been promising full self-driving for years now. We're not going to get there because those kinds of models are simply, they're the wrong architecture. If I've got to build a nuclear power plant,
someone with experience actually is talking to you. That's when I'm looking at this.
to build my systems, I'm probably doing the wrong architecture. And so, yes, I think that if I've got to build a nuclear power plant to build my systems, I'm probably doing the wrong architecture. And so, yes, I think there are valid use cases for large language models, but we have to be careful because they are indeed dangerous. Jan blocked me on Twitter because at the very beginning of their work, Galactica, I called him out on it and said, you know, Jan, this is
Jan Legun. This is Jan Legun. You cannot call you like that, man. Jan Legun. But in any case, yeah, Jan Legun. Okay. Now I get it. Mm-hmm. No. Again. DeepSeek Air 1 is here. But yeah, the metrics that they use in Core 4 GPQ Diamond Math 500 is based on that. OpenAI 01 is this. But in any case, good, bro. Good, bro. So, this has been a long video, bro. This has been a long video. But the point of this is to at least gain perspective of what are the things that we need to do, especially as we build this kind of React Native applications. And by exploring ideas of how do we get here, if you're going to provide this app to all right. So the idea here is that if we are going to build this kind of apps, this React Native application, it's important to understand that the process from setup, build, and the setup, build, publish, and then monitoring of processes, and especially if you want to provide or you want to now provide some consultant to these big tech companies, or at least companies at least in companies in industry where they have huge impact or where their accountability is something that is important or is critical for them. So, such as the financial sector or the medical, the healthcare sectors. Now, on that is to understand that despite all of this, it is quite important to have this architectural or this visualizations, specifications, and description of the systems using UML. And how this allows us to describe is the systems from the user story, the logical, the activity, and the deployment here. This is a conversation for big boys, bro.
This is great stuff, but you realize the implications, and he simply dismissed them. And I kept calling him out. He got tired of me doing so and eventually blocked me. But this is another I told you so. We have seen the joys and the dangers of large language models.
So just to double click on this, it sounds you're saying that large language models by themselves will not get us to AGI. But do I understand that if we combine it with other tools like neural nets or neural symbiotic systems, we can actually get closer to these intelligent systems? And if we take this example that you just said, a robot on Mars that is able to clear filters and follow instructions, what do you think we would need to get to that type of intelligence?
Right. And I even add to this, if you look at cultures such as Japan, where you have an aging population, a shrinking population, the US is very much in this place, you have tremendous need for elder care. And so the robotic use case, and not just the full humanoid robotic use case, comes into play. There are clear and present needs for these kinds of things as well too. So yes, there are lots of great use cases. So I've always believed this to be a systems engineering problem, which is why if you go back to the architecture of self, that's why I've been focused upon neurosymbolic systems. Now, let me get a little philosophical for the moment. I'm pretty sure you're sentient. I can't guarantee it, but I'm just guessing that you are, and you're not some amazing large language model. And why do I think
guess.
that?
You're not some
It's a
amazing
fair
large
guess.
language model.
And why do I believe that? It's because I have a theory of mind about you that through multimodal ways in my interactions with you, I have a theory that says you're sentient. You're someone who has
Fair
its
use.
own agency, who has your own feelings and behaviors and needs and the like. And that's cool. You're not a robot. And so the human mind has evolved over millennium to develop that through an architecture that, yes, it's neural in nature, but on the one hand, artificial neurons are not a shadow, they're an echo of a whisper of what organic neurons are. They are a small piece of it. Furthermore, if you look at the architecture of large language models, which as you observed are relatively simple, there's a simple layering to them which ignores the exquisite complexity of the human mind. We have in our cerebral cortex cortical columns. We have tens of millions of them. They're in humans about 7 layers deep. Reptiles have them as well too. They're a bit smaller. Those are the ones that appear to be the place our homunculus work, where we build the predictive models of the world. But we also have places where emotions and other decision making take place among these entangled architectures associated with the thalamus and the like. And furthermore, we have other things going on with it appears to be our hormonal system, that appear to be other ways of message passing within our neural networks. So in that same regard, large language models are interesting, but they also are a whisper of a shadow of, I think, what reality is. And so where the next level is, and Gary and I have observed, we're reaching diminishing returns on what scale can do. The OpenAI folks and Elon believe scale will continue for a long time. Gary and I are saying, no, we're reaching a limit there. You need to think about it in other ways. That brings us back to those architectures. The last thing I'll mention is at the very beginning, you talked about me being involved with embodied cognition. That brings me back to my roots again. What is embodiment? It's building systems that are in and of the world, that respond to the world and act in the world. Large language models are largely unimodal.
Exactly. That act in the world and response in the world.
They work through text, maybe static images woven together through video and the like, but they're very sensory sparse. Our minds and our intelligence have grown because they've been embodied in the world. In that regard, I think there are many kinds of intelligence that exist, but our human intelligence grew because of our embodiment, and it's going to require some fairly complex architecture to get that. That's why I've been studying human architectures for 6 years, because I don't know enough about them. Let's see if that influences the way I build software architectures.
And as closing, you previously tweeted something really interesting around this analytical
That's why he mentioned is
that brings us back. We have other things
here.
going on with it appears to be our hormonal system. So in that same regard, large language models are interesting, but they also are a whisper of a shadow of, I think, what reality is. And so where the next level is, and Gary and I have observed, we're reaching diminishing returns on what scale can do. The OpenAI folks and Elon believe scale will continue for a long time. Gary and I are saying, no, we're reaching a limit there. You need to think about it in other ways. That brings us back to those architectures. The last thing I'll mention is at the very beginning, you talked about me being involved with embodied cognition.
Embodied cognition. Embody cognition. Okay. Embodied cognition. Embodied cognition is a theory that suggests that cognition is shaped by the body's physical state and interaction with the environment. Then. Embodied cognition. Oh, okay. La concepción del cuerpo o la cognición del cuerpo. Embodied cognition. Es una teoría, amigo. Oh, que es el cognitivismo. Cognitivismo y computacionalismo. El dualismo cartesiano. Puta madre. It is closely related to the extent mind, situated cognition, and enactivism. Cognition, the theory. Theory of cognition. Oh, okay. A cognitive model as illustrated by Robert Flew. A cognitive model illustrated by a model. Auditus, visus, odor, tactus, and terra, mundos sensibles. I love these Latin words. Mundus sensibles, mundus imaginables, mundus intellectualis, where is Dios, mens intellectuals. It's interesting because it's human intellectual, but it's okay. We also want to step woman aside, but in any case. That makes a lot of sense. Okay. The theory embodied cognition.
That brings me back to my roots again. What is embodiment? It's building systems that are in and of the world, that
Exactly. It's building systems that in and out the world
respond to the
respond
world
to the
and act
world.
in the world. Large language models are largely unimodal. They work through text, maybe static images woven together through video and the like, but they're very sensory sparse. Our minds and our intelligence have grown because they've been embodied in the world. In that regard, I think there are many kinds of intelligence that exist, but our human intelligence grew because of our embodiment, and it's going to require some fairly complex architecture to get that. That's why I've been studying human architectures for 6 years, because I don't know enough about them. Let's see if that influences the way I build software architectures.
And as closing, you previously tweeted
No,
something.
and he mentioned something important is that the computer science, the boon of computer science is because for the U.S. agency, the U.S. government, it requires a lot of work to organize all of these paperwork with the boon of citizens, with the boom of birth rate. Now, since we are living in a decline birth rate, all right, it makes a lot of sense to now invest our time and efforts in this kind of machines, in the autonomous machines and all that kind of stuff. So, therefore, is to invest in anything that is related to that field. The field of robotics. The field of robotics. Makes a lot of sense. Exactly. Cycle JavaScript framework for robotics. Next generation robotic framework with support for 43 different platforms. The hello world of things. Cyclone has an extensible system for connecting to hardware device. The following robotics and physical computing system and software platform are currently supported: Air Drone, Arduino, Arduino Jump, Audio, Beagle, Bebop, Bluetooth, Crazy File, DigiSpark, Electric Imp, Intel Galileo, Intel Edison, Joystick Keyboard, Leap Motions, MIP, okay, MQTT, message queue, MQTT, really? Holy this is on the Internet of Things, connectivity protocol, mesh protocol featuring a lightweight publishes subscribe messaging transport, and it is useful for it as a small scale footprint and minimal network bandwidth usage. Nest, Neurosky, Octoblue, OpenCV, Particle, People, Philips Hue, Pinocchio, PowerUp, Rapido, Raspberry Pi, Salesforce, Speech, Sphero, Sphero Blue, Tessel, and Sense. Analog support, relay, and server support for devices integrated circuits. This is quite interesting. Very, very, very interesting. Very, very, very interesting, bitch. Especially from the keyboard here for keyword inputs. So you can have access to the keyword, and then you do this. How to connect to do is plug the keyword into your computer as usual. Driver availables, the keyword platform are listed. So, and it is emitted all of this in one, F2, and backspace, delete, home space. Holy moly. Multiple solutions, R2 and GoBot. Is there any examples of this? Oh, I get it. Okay. Leap motion. Meep. It's a self-balancing autonomous robot from Woo-Wee. It can move, dance, talk, and more. What the French does? And OpenCV. It's an open source computer vision and machine learning software library. OpenCV was built to provide common infrastructure for computer vision applications and accelerate the use of machine perceptions. Okay, this is something quite interesting in terms of putting a test what to do and how to do this. This is controlled programmatically. Air drone flight, air drone navigation. Arduino and Arduino Jump. Arduino, audio, and this kind of stuff. Bebop, BLA, crazy files. So he mentioned that this embodied systems, which is part of the theory of this will make a lot of sense to now use to now provide some solutions to that. Makes a lot of sense. Makes a lot of sense. To provide solutions to that. And especially as the populations grew old, yes. As the population grew old, even including myself, as I grew old, and then I don't, okay, as I grew old, and now I will require more, again, this is something that I don't think that there is an incentive of putting, of maintaining unproductive, there is not an economic incentive that's what happened. There is not an economic incentive here. There is not an economic, or at least there is, the economic incentive is to all the money that you have reaped in your youth, now you're gonna pay that. Yeah, you're gonna pay that. Octoblue, Phyllis Hue, Pinocchio, Power Up, Bebop. The Pirate Bebop is the next generation of drone featuring a dual-core CPU, quad door, and 8 GB of flash memory. The Bebop also comes with 14-megapixel camera and generates its own hotspot. And it generates its own Wi-Fi hotspot. God damn it! All right. Bebop drones. I get it, man. Bebop drones, of course, bro. Bebop drones, man. About Parrot, SDK solution programs. Bebop drone, bro. Jesus, French toast guy. SDK program, partner solution. Cat modeling. From the design and to build this kind of stuff. Anyway, again, this is a very interesting topic that I think is something that will have more impact on here, robotics, the rise of GS robotics, Arduino base kits, and all that kind of stuff. Find a meetup near you. Blink everywhere. There is something in Argentina? No, Argentina, no, come on, man. Mexico, UK, and Colombia. Medellin. Okay, so Medellin is our way to go, bro. Okay. Yeah, but Oh, but this is from Mercado Libre, no. And it makes a lot of sense. Yeah. Good, but again, this is something that it can be quite off. This is a long-term vision.
Really interesting around this, and I'll quote this. You tweeted, "We need a standard way of visualizing the architecture as well as the activity of LLM and to generalize any artificial neural network, sort of a UML for AI." Now, this was a year back. Have you seen anything happen here? And why do you think LLM architecture is so important?
In fact, I have seen both. I have both thoughts, and I have seen movement. So internally, I've been helping out with providing a little bit of architectural adult supervision in our large language model work, and I've been trying to figure out what's the way to visualize the kinds of things we're doing. Turns out it's still very UML-like, that these are now boxes that are systems unto themselves, and they're message passing systems along the way. So I'm trying to figure out the best ways to do that. As you may know, just this week, AlphaFold released its source code and weights publicly. So I'm jumping on that, and I'm going to use that as a basis of, can I describe the architecture of AlphaFold 3 using some UML deliberative? So stay tuned. I think there's work to be done in that regard.
And what advice would you have for software engineers who are just starting out the software industry? There's plenty of recent graduates who find themselves in a chilly job market. There's a threat of what feels like AI tools changing how we do software engineering. You've gone through a lot of cycles of innovation in software engineering. What advice do you have for those starting out to set them up for a successful software engineering career?
Indeed, when Copilot and ChatGPT came out, I received a flood of messages from folks saying, my gosh, have I chosen the wrong career? Because you're not going to need developers at all. You will always need people who make informed decisions.
That's what happened, man. You always need people that need to make informed decisions. So it is interesting because it is up to us that we know that there is certain stuff that we need to be done, that need to be learned and absorbed to actually take decisions. And those decisions will be rewarded for our own needs.
No matter what the language is. Software engineering, again, is one of rising levels of abstraction. It's just that our tools have changed. I learned to program in assembly language. People today are going to be learning in programming with languages that are at a much higher level of abstraction. So the advice I'd give such folks is twofold. Don't worry, don't be afraid. There's always going to be some really cool work for you to do there. And in fact, I would say it's quite the opposite. This is an exciting time because there is so much opportunity, so many cool tools, so much computational resources that in many ways you are limited only by your imagination. And so what I encourage people to do is to first learn as much as you can.
Which is that, man. Learn, and again, this is something that must come from you. It is up to you, man. Learn and do that in a systematic way. Learn as much as you can in a systematic way to solve your own problems. And in this case, is to learn, to understand, and to be able to articulate all of these complex ideas, and therefore translate that here as it is.
Second, don't get stuck in just one domain. You need to become an expert in some space, but the world of computing is vast. And so find some space that nobody's in right now and go make a name for yourself there, because there are lots of those kinds of places there for you. And the third thing I'd advise is go have some fun. I mean, my gosh, the toys we have at our disposal, they're amazing and wonderful and cheap. There's so much a single person can do at so low expense to go change the world. I'd like to also close by saying I'm not done yet either. I'm having a tremendous amount of fun. And in addition to the things I told you in studying the human brain and working with large language models, there are two projects that I'm engaged in that I've been working with for a long time now. The first is I've been trying to write a book on software architecture. I'm glad I did not write it because I know so much more now than I did before. And this is a different architecture book rather than saying, here's how you do it.
Exactly. We always actually is looking for how-to recipes. No, man. If you truly want to know something, the how will come up.
With a number of companies to document their as-built architectures. So I'd like to put AlphaFold in it. Photoshop is in it. What's the architecture of Photoshop? What's the architecture of a climate monitoring system? What's the architecture of Wikipedia? So I'm trying to document the as-built architecture of systems that people use today that they may never have thought about. The idea being is that there are many different architectural styles. Let me expose you to them because you may have studied only one particular one. The world is a vast one. The second is,
and just to confirm, this is the Software Architecture's Guidebook, right?
Yeah, the Software Architecture Handbook. Which my long-suffering editor has been has been patient with me for literally a decade now, and it's something I hope to finish before I die. The second book is, I was on the board of trustees for the Computer History Museum for about 10 years, and we'd hired a new CEO. He came to me and said, he had been at PBS. We had a conversation and said, hey, John, why don't you do a documentary like Carl Sagan's Cosmos? He paused and said, well, Grady, why don't you be our Carl? And I said, I'm no Sagan, but that's an intriguing idea. So I've been on a journey to do a documentary, and I'm writing a book about computing and the human experience, which looks at the history of computing and what it means to be human. So I'm looking at, what does computational thinking look like? How has computing changed the individual, society, nations? How has it changed science and the art and religion and such? And ultimately it asks the question, in the presence of computing, what does it mean to be human? So that's the larger project I'm working on right now, which I hope to finish up also before I die.
And let's wrap up with some rapid questions. So I'm just going to ask and then just shoot. You don't need to think too much about it. What was the first programming language that you used?
Fortran.
Holy moly.
Fortran. What project did you commit code most recently, and what language did you use in it?
Most recently, my own language, my own project self, Python.
Python. What do you do to recharge from doing software engineering related work?
I live in Maui.
Man, I hit the gym. You know, I hit the gym daily, bro. Daily. I don't skip that F. I take sun. I take 15 to 30 minutes of sunlight every day. Try to do that early in the morning, and then hit the gym every day. Eat healthy, and then let my mind wander as well.
I wake up. That's enough.
Yep. Enviable place. And also answer. What are 2 books you would recommend for those who would like to understand more about software architecture?
Mary Shaw's book, Software Architecture.
It's interesting. It's like, why enviable? You say, beautiful place. I've never been there. I would like to be there. Hopefully, I just look at some photos, and yes, it's like, it's not envy. You all people talk from envy places. It's like, you envy something that you don't understand. How to get there.
That one. Other books kind of
maintain
pale in
that.
comparison, but I'd start there.
Well, thank you very much, Grady, for being on the show. This was really interesting and fascinating.
So in any case, I mention all of this because this was just the huge intro in terms of looking at how can we build now this kind of application. Small, tiny, little apps here that is just a plant watering app. Okay, and how now, from this small stuff, how do we scale that up, or how this connect to other concepts that are relevant, especially as the service that you're going to provide to any of all of these big companies and those industry now demands that. And that is like, hey, perhaps for these startups, you don't want that. You don't require to do that, which is great, which is fine. Mm-hmm. So yeah, it all start with this, okay. Even though that is actually took huge amount of time to understand that, but I think this is very revealing in terms of how do we get here, what we're gonna do, and therefore now have a more broad perspective of what we actually do and then finally do it. So this is something that we're gonna do tomorrow. So that'll be all for this video. Take care. Bye-bye.